Kids. All right, welcome back. All right, so here's our problem. I drew it out. So we have a 5 amp. I decided I'm going to make that one go up. That means 6 amps is going to go down. Guys, you need to use 2 colors. So if you need to pause this and go get 2 colors, do it. Because you have to have 2 different colors. I'm using purple and red, but you can use whatever you like. But use 2 colors. When you do your homework tonight, you will use 2 colors. Do you understand me? Repeat after me. Yes, Mr. Lindenberger, I will use 2 colors. Yes, Mr. Lindenberger, I will use 2 colors. All right, so we're going to use 2 colors. Okay, so that's our setup right there. Now remember, around the 5 amp wire, there's a magnetic field. Around the 6 amp wire, there's a magnetic field. When these 2 magnetic fields interact, you get a force. So that is where we're going with this. So let's talk about the 6 amp wire first. Okay, so if I have the 6 amp wire here, okay, to the left of the 6 amp wire, if you do your first right-hand rule, thumb points down, my fingers are going into the page. So that means every place over here, the magnetic field is pointing in. All over, everywhere over there, okay? Every place over here, the magnetic field is pointing out. Every place over there. So I have dots everywhere over here, okay? But, guys, to make sure you guys understand this, remember, I only care about the magnetic field where this 5 amp wire was. So I only care about the magnetic field. If here's my 5 amp wire, okay, I only care about the magnetic field right on it, okay? I don't care about it here. I don't care about it here. I only care about it right there. So that when you guys draw this, okay, let me get this cleaned up for us. Okay, so here is my picture. When you draw this, okay, it is true. Every place to the left of the 6 amp wire, the red wire, the magnetic field is pointing in. But I only care about the magnetic field right here because that magnetic field is going to be the magnetic field that causes a force on my purple 5 amp wire. So guys, just draw your X's there. And again, it is X's because of that. It is not always going to be X's. Okay, you got to use your brain. Okay, for the other one, if you guys take a look, so if I want to find the direction of the magnetic field where the 6 amp wire is, then I'm going to use my right-hand rule. I am to the right of it, so that my magnetic field goes around and points in. So that means I'm also going to get X's. Okay, so that means if I was to ask you to find the direction of the force on the 5 amp wire, use your second right-hand rule. Your thumb points up, fingers point in, and your force is going to be to the left. So thumb's going up, fingers in, your force is going to be on this wire, is going to be that way. Okay, the force on the other one, thumb points down, fingers point in, your palm points to the right, so the force is that way. So if you look, these 2 forces would cause the wire to repel one another. Okay, so this is going left, this is going right. Will that always happen? Of course not. Okay, that you just have to look at the current, and the magnetic field, and then do your right-hand rules. But in this case, they are repelling one another. Okay, so now what we're going to do is we're going to I'm going to pause this again. And we're going to figure out how to find the magnitude of the force. So right now we know the force on this one's pointing left. Force on this one's pointing right. Force is a vector. Now we need to find the magnitude. All right. Be back in a minute, kids. Bye.